Okay, so am I audible? Richika, am I audible? Please respond me. Anyone? Am I audible or not? And my whiteboard is
Yes,
visible or
sir.
not? Okay, okay, okay. So last classes we have discussed in our control system, that is a stability analysis. This is the gain phase plot. How to plot the gain phase plot for the stable system, and another one is the unstable system. Then we have to learn the closed loop frequency response analysis of a unity feedback control system from the Nyquist plot. So another new topics, this is very important for your syllabus, that is a stability analysis. This is the constant magnitude loci, that means the locus also, and this is the call, that is the M circle. Okay, so now this is the constant magnitude loci, or sometimes it is also called the M circle. The open loop transfer functions transfer functions, and you know that in the open loop transfer function, that means here no feedback system, that means no feedback loop it is required. So only the processor, that is a planned controller part we have to attach, that is a gj omega. Okay, so of a unity feedback control system is a complex quantity, and can be expressed as, we have to return the open loop transfer functions. This is the g j omega dot unity feedback system. That means the hs value of the hs feedback factor, that is also 1. And this is when you have to return the transfer function in the complex equations. This is the x plus gy. And previously we have to learn, just previous class, that is the transfer function, that is the m equals to the output of the system, that is c j omega by r j omega. It is equals to, we have to learn, that is g j omega by 1 plus g j omega for the unity feedback systems also. Okay, now you have to put this value, that is the g j omega, this is equals to this one, we have to put this value into this equation. So the equation is coming, that is m equals to x plus gy divided by 1 plus x plus gy. This is the one equation 1. Now you have to calculate, that is squaring the both sides. First we have to take the, that is mod of m, this is equals to root over of x square plus y square, and lower part, this is 1 plus x square plus, this is the y square. This is the another, sorry, another equation 2. Now on squaring both sides of equations to these equations and simplifying following equations is below. Okay, so you have to calculate these equations. The equation is coming into this pattern, that is 1 minus m square into x square minus 2m square x, sorry, this is x, plus 1 minus m square into y square. This is equals to the m square. Okay, so this is the another equation 3. So you have to calculate it, you have to squaring both sides these equations and simplify the expressions. The expression is coming these patterns also. Now you have to arrange these equations, that is or x square minus 2m square divided by 1 minus m square. We have to return this equation from this. Okay, then also into x plus y square. This is equals to m square by 1 minus m square. Okay, so you have to multiply these equations. You have to multiply this one to this one. This is coming. Then 2m square x. This is also coming. Plus then y square into 1 minus m square. It is also coming. So these are these equations. This is that is same thing. So we have to arrange these equations into these patterns also. Okay. So we have to do the next page. Adding, that is the m square by 1 minus m square, this one, to both sides of equation. We have to give the equation number. This is the number 4. That is the equation number 4. So equation is coming. This is the x square minus 2m square by this equation. Okay, that is the 1 minus m square into x plus we have to adding, that is the m square by 1 minus m square, its total, so whole square, plus previous part, this is the y square and then this one. So this is the y square, this is equals to previously this is present m square by 1 minus m square, and we have to adding, these are the m square by 1 minus m square, its totals of whole square. Okay, so now you have to calculate it. So this is x minus m square by 1 minus m square, okay, plus y square, this is equals to m by 1 minus m square. This is the another equation 5. So you have to easily calculate this equation. Okay, here x square minus these are 2 into a into b and the b square. So we have to written here a minus b whole square formula. Okay, this three part is the formula of a minus b whole square formula. then y square, then you have to calculate this one also, you have to multiply this. So here you can see there are difference value when you have to uh, different value you have to put at the m, that is the for different values of m equation 5, this equation it represents a family of circles with center at, that is x equals to m square by 1 minus m square. This is caps m. Okay, where y equals to 0 and radius as m by 1 minus m square. Okay, so on a particular circle with the value of m, that is the magnitude of closed loop transfer function. This is CLTF. We know that it is the closed loop transfer function is constant. So these circles are called the M circle. Okay, so this is the required M circle. So I just conclude this position also. So you have to consider here the unity feedback system, that is the open loop control system. So this unity feedback control system you have to written in the complex form. This is the x plus jy. We know the previous, that is the output of the transfer function, that is the output of the system by input of the system. We have to put the value of g j omega in the complex form. Then you have to squaring both sides these equations also. You have to simplify this pattern. Then we have to adding these variables in both equations. The value is coming this pattern. So in this different value, when you have to changes the different value of m in this equation, the value it is also changes both sides also. So this is the represent a family of circle with the center of the point, that is x equals to m by 1 minus m square. And at that point y equals to, that is a 0. So radius on a particular circle with the value of m, this m, it is the magnitude of the closed loop transfer function is constant also. So these circles, it is called the m circles. Okay, is it okay, all of you?
Yes, sir.
So now we have to prepare one table, how it is value is changes and pattern is coming in the circular. That's why it is called the M circle. Now prepare the table of the M circles. Table of M circles. So first we have to written here. This is the different value of M. Then another, that is the center, and here value is, that is x equals to m square by 1 minus m square, and here y equals to also 0. Another one, radius. It is expressed, that is r, small r. This is m by 1 minus m square. So everyone draw the these tables. This is very important when you have to put the value of the M circles. This is the little bit pattern of tables. So first we have to put that is the 0.5. That is the value of M is 0.5. So you have to put this value, okay, 0.5 into this equation. So you have to calculate it. The value is coming 0.33. And you have to put this value into this equation also. The radius is coming 0.67. Okay. So this is very easy. So then when the value of magnitude it is 1, when this value it is 1, this value it is coming infinite, and this radius it is also infinite. You have to put this value, that is 1 and 1. That is 1 by 1 minus 1, that means 0. That is 1 by 0. Okay. So this is the value of the center of x. This is the infinite range, and also radius it is also infinite. Then you have to put the value, that is a 1.2. You have to calculate, you have to put the value of M equal to 1.2. You have to put at this value and calculate it. The value is coming minus 3.27, and also this value it is coming 2.73, and so on. You have to change the value, different value 1.6. This is the value is coming minus 1.64. This is the 1.03. Another one we have to put it, that is the 2.0. So here the value of M is 2. You have to calculate the value, that is minus 1.33, and this value it is coming 0.67. Okay. So this is a rotated. Here you can see this is also rotated, and this is also another one which is a negative region also. Then you have to put the value 3. That is also same. That is a 1 point minus 1.13, and this is the coming positive of the radius, that is 0.3, and so on. This process it is continuing. So here you can see this is the basically table of the M circle, where you have to change the different value of M, that is the magnitude of the system. When the value is changes, that is the M is changes, the center value it is also changes, and radius it is also changes. Okay. So now we have to consider the circles of the M circle. So diagram is coming. This is a x-axis. Another one, it is also y-axis. So I'm trying to circle, but just wait 1 minute. A little bit. Uh, these are the first circle, another one. These are the another new circle, and we will consider this is the next circle. This is the axis of x, and here the value of M equals to 0.5. This is the center point O, and the radius is 0.33. And when the M equals to 1, the value, that is M equals to 1, then this part where m equals to 1. In the tables you have to follow, when m equal to 1, the center of the radius it is also infinite, and the radius it is also infinite. So here you can see, so that's why this is not circle position, this is the straight line. This is the infinite range, another one it is the infinite range. Okay, and next, this is the another part, that is a minus 1.13, when you have to put the value that is m equal to 3. So these circles, it is the called the different value. When you have to change the different value of m, first we have to put the m equal to 0.5, then m equal to 1, and so on. That is m equal to 3, m equal to 1.6. So these are the different circles we have to come. Okay. Okay. So we have to follow this table. This table, it is called the m circles. Is it clear? Is it clear or not? This figure name is m circle. Is it clear, all of you?
Yes, sir. Yes, sir.
Okay. This is the different value. Okay. So we go the next. Next is another last part in our stability analysis. This is the M circle. This is the M circle. Another one is the M circle. This is the constant phase angle loci. That is the locus also. Sorry, this is the M circle. Okay, this is another part. So when you have to consider the closed loop functions for the unity feedback system, that means HSE, that is the Hj omega value is also 1. So now in the previous equation, I just written the equation. Then you have to remember. We know that that is m equal to x plus jy by 1 plus x plus jy. We have discovered in the previous equation. Sorry, this part also. Okay, this one. I am written this equation also. So now, so this is m equals to the complex equation, complex function, that is x plus jy by 1 plus x plus jy. Now, the phase angle of closed loop transfer function, that is CLTF, closed loop transfer function of a unity feedback control system is given by this is angle of output of the system by input of the, that is angle of Cj omega by Rj omega. So we have easily written this is equals to x plus jy by 1 plus x plus j. And this is the equation number 1. Okay, so first we have to express this is the phase angle. So phase angle, that means phi. So phase angle is denoted, we know that previously, by phi. So therefore, the previous equation we have to written. Therefore, this is phi equals to, we know that the equation that is tan inverse y by x, okay, minus tan inverse y by 1 plus x. This is the equation of the phase angle of the phi in the given transfer functions also. Tan inverse y by x minus tan inverse y by 1 plus x. Now you have to take the both sides for the tan. So we have to written this equation, that is tan phi. This is equals to tan of this equation. Okay. Minus tan inverse y by 1 plus x within third bracket. Now you have to put the value, that is a formula. Okay. So you have to put this formula, that is tan inverse A minus tan inverse B. We know the formula in your algebra part. Okay. So this is the basically formula I'm written here, that is the tan into tan inverse y by x. This is x minus tan, third bracket complete, also tan inverse y by 1 plus x divided by, we know that 1 plus tan A tan B. Formula it is tan A minus tan B by 1 plus tan A tan B. Okay. So 1 plus tan of the angle, that is the tan inverse y by x dot tan into tan inverse y by 1 plus x. Okay. Up to this part it is clear. This is simple. This is, you have to apply the rules, that is a law formula. This is the tan inverse A minus tan inverse B. Formula is, that is a, this is a tan and tan, this is same. That is tan inverse A minus tan inverse B by 1 minus tan inverse A dot tan inverse B. Now you have to consider these tables. We know that tan into tan inverse, that means this tan and tan vanish, because this is the tan into tan inverse, that means tan into 1 by tan, that means tan it is invisible, that is a vanish, that is the angle it is present, that means only y by x minus, this is also same, that is y by 1 plus x divided by, I think 1 plus this one y by x into, that is y by 1 plus x. This is clear, all of you, how it is coming? Is it clear?
Yes, sir.
Only Gautam is response and otherwise not response. तो आप लोग क्लास में आते हो, मतलब क्लास ऑन करके चला जा रहे हो, घूम के आ रहे हो 40 मिनट्स के बाद अटेंडेंस के लिए, रेस्पॉन्स नहीं दे रहे आप लोग. सुषमा कुमारी, आर यू हियर मी?
Yes, sir.
Is it clear?
Yes, sir.
And others? There are 21 participants, including me, but response is only 1 and 2. So this is very bad impression.
Yes, sir.
Okay, everyone please respond me. So this is the basically required equations we have to draw from the phase angle. That is the phi equals to this one. So now this is phi, that means the tan phi. Next, So we have to solve these equations. That is, the equation is coming tan phi. This is equals to y by x squared plus x plus y squared. This is the equation number, I think, 2. One is given and 2 is another. Now substitute tan phi. This is equals to n in equation 2. So the equation is coming, that is n equal to y by x squared plus x plus y squared. Okay, how it is coming? Please everyone solve it in your rooms. It is basically simple calculation in your algebra part. Then after calculation, this equation it is coming this pattern. And this tan phi we have expressed in our stability analysis. This is equals to n equals to, this is the value. So now we have to simplify this equation. We have to written this is x squared plus x plus y squared minus y by n. This is equals to 0. Okay. Next, add 1 by 4 plus 1 by 4 n squared on both sides. In equation, this is the equation number 3. Equation 3. So equation is coming x squared plus x plus 1 by 4 plus y squared minus y by n plus 1 by 4n squared. This is equals to 1 by 4 plus 1 by 4n squared. Now we have to calculate it. This is a plus b. This one a square plus 2ab plus b square. You have to calculate it. This is the basically a plus b whole square minus another one. It is also same. This is the 1 by 4 plus 1 by 4n square. Okay. So this is the equation 4. So here for different values of equation 4, it represents a family of circles with center, that is x equals to minus half and y equal to 1 by 2n. This is half. And the radius is 1 by 4 plus 1 by 4n square. Okay, so now we have to prepare the table. Okay, that is the table of the n circles table. This is the value of angle of phi. Another one, that is n equal to tan phi. Then this is the center. This is x equals to, we know that, minus half, and y equals to, that is equals to 1 by 2n. And another one is the radius. That is the, we expect, that is r. This is equals to 1 by 4 plus 1 by 4n square. Now we have to prepare the table of the n circle. So first angle of phi you have to consider here minus of 90 degree. So you know that tan 90 tan 90 degree, this is the value of infinite. So when this infinite, that means the center point it is also 0 and radius it is coming 0.5. Then angle of 60 degree. So you have to calculate it from your calculator. The value is coming minus 1.732. Center is coming 0. This is minus 0.289. Radius is coming 0.577. And so on. You have to consider the another 150 degree. So you have to change the value one by one, and the value is also changes one by one. Then you have to put minus of 30 degree. The value is coming, that is minus 0.577, 0.866, and it is also 1.0 radius. Then the center point, that is 0 degree. When this is 0, this is also 0. This is infinite. This is also infinite. And another we have to miss it, that is a minus of 10 degree. The value is coming 0.176. This is minus 2.84, and this is the coming 2.88. Then you have to put the positive of the angle, the plus 10 degree. That is the value is coming 0.176. The value it is also changes. The center 2.84. Radius it is also coming 2.88. Then plus 30 degree. That is also 0.577. You have to explain this. These are basically same thing. One is positive, another one is the negative. Okay. Then plus 50 degree. So everyone write your own name and roll number in the chat box. And Gautam is present.
Yes, sir.
So take another screenshot.
Yes, sir.
Okay. So you can see the value it is also same, but sign is also changes. That is, one is negative, another one is the positive. So this is the 1.732. Also this value is coming 0.289, and this is also 0.577. Last one, that is the 90 degree. This is infinite, you know that. Then the center point, it is also 0, and the radius is coming 0.5. Okay, so this is the basically value of the different in circles. So diagram, it is coming. This is the x-axis. This is the y-axis. Circle, it is also same. First one, another one. Okay, so this is intersect another point also. Like this pattern. These are the different angles. One is 30 degree, another is 60 degree. Okay, this is the positive region. One, this is one, this is two, this is little bit -1 or -2, and so on. So this in circle, it is coming between the this y-axis